Hi. In exercise C-3 we are to design drivetrains for the 4 conveyors. The conveyors are different in their load profiles, or more specifically in their overload profiles. So the rated parameters are the same, both the torque and the speed range are the same. And we need to work just with air-cooled drivetrain variants because cooling water is not available. So we are basically in this exercise to find out how overloads define our choice of the drivetrain components. So this exercise is about overload capabilities of the electric machines and the frequency converters. So let's try to set up overloads in DriveConstructor to see how they affect the drivetrain design. So first, of course, we choose the right topology and set up the parameters. And we see for this one we have 3 motors, permanent magnet motors are there by default, and we choose one of them and see that the load curve and overload curve for the motor are perfectly positioned. So that was for the case with 20% overload, but we try different overload now. We take 100% overload, 2 seconds every 60 seconds, meaning every minute. And we see the motors now are bigger, so DriveConstructor chooses bigger motors because the motor can handle just 50% overload if it is a permanent magnet motor. So please note that induction motors, they hold higher overloads than PM machines. So we choose one motor and see how the curves are positioned, and this is actually an interesting case here because we go into the overspeed area. So now let's check another case with a longer overload. So we used to have 2 seconds each 1 minute, and now we're going to have 1 minute each 10 minutes. So 60 seconds over 600 seconds. And we see the motors now are much bigger than before, more expensive and heavier. And if we take the cheapest one, we can also go down and see at what the frequency converter we got. So it's quite a big frequency converter. It's bigger than in the previous case, and we see the load curves. The overload curve was just at the limit. Now let's try a longer overload. Not 1 minute, but it's going to be 2 minutes, 2 minutes each 10 minutes. So that means a 1200 seconds cycle. So let's see what we get for the motor and the frequency converter in this case. Yeah, the motors are of more or less the same cost and size as in the previous case. If we take the cheapest one, I know it doesn't find any converter. If we take this one in the middle, then we get a frequency converter, and it is the same size as before as well. So again, let's try another case now with 50% overload, 1 minute every 10 minutes. So first we correct the overload to 50%, and now the duration of the overload should be reduced to 60 and the cycle to 600. So let's see what happens to the motors. So the motors are smaller and lighter and cheaper again. We take the cheapest one, and the frequency converter is also down in power. So DriveConstructor then chooses a smaller frequency converter. And you see both load curve and overload curve are just on the limit, so it's good sizing. But we can also try induction motors. Induction motors, they have higher overload capability, not 50% but 100% overload capability. So this can be in certain cases a better solution than the PM. So all this have to be checked and tried. So the results of your designs should be summarized in the table like the one on the screen. And here the point is to show the difference between the overload capabilities of the electric machine types and frequency converter types, and basically to answer what is the difference between the electric machine overload capability and frequency converter overload capability, and how the thermal cycling inside the electric machine and inside the power stage of the frequency converter are different in this respect. So also to show the implication on the cost of the machine and the converter and the total system. Thank you for watching.